Objects and classes work together. We cannot talk about one without talking about the other. And the entire point of object-oriented programming is not about objects, it's about classes. Because we use classes to create objects. It defines the shape and nature of an object. As such, the class forms the basis for object-oriented programming. So, a class describes what an object will be, but it isn't the object itself. A class is a blueprint from which objects are actually made. If you want to build a house, you make a blueprint first. It describes everything about how that house will be built, but it isn't the house. You then use that blueprint to build the house. Think about classes as cookie cutters. Objects are the cookies themselves. In software development, we write the class, then use the class to create the object. And just as we could use the same blueprint to build any number of houses, we can define the class once and then create as many objects we want based on that one class. Perhaps the most important thing to understand about a class is that it defines a new data type. Once defined, this new type can be used to create objects of that type. Thus, a class is a template for an object, and an object is an instance of a class. When you define a class, you declare its exact form and nature. You do this by specifying the data that it contains and the code that operates on that data. While very simple classes may contain only code or only data, most real-world classes contain both. A class can also contain other classes. Another helpful way to think about the relationship between classes and objects is to think about the similar relationship between types and variables. In procedural programming language, when you talk about the type of a variable, integer, floating point, or string, you are using shorthand to describe the range of data that the variable can store, as well as the operations that can be performed on that variable. For instance, integer variables cannot hold fractional numbers. Similarly, you can multiply integers and floating point numbers, but you can do spell checking only on strings. Variables hold values, types do not. A type is merely an abstraction. To actually hold an integer value, you have to create an integer variable. A variable is an integer if it follows the blueprint for creating integers, specified as the integer type. Rules within the integer type determine what data integer stores and how integers act. Individual integers I, j, and k are called instances of the integer type. Objects and classes have a similar relationship. A class defines the attributes and behaviors that each object created from the class will possess. The data or variables defined within a class are called instance variables. The code is contained within methods. Collectively, the methods and the variables defined within a class are called members of the class. In most classes, the instance variables are accessed by the methods defined for that class. Thus, as a general rule, it is the methods that determine how a class's data can be used. So a class has an identifier that is the name of the class. You will use the name to declare objects of that type, and it describes two things: attributes and behavior. What attributes, what pieces of information will describe each object? The class definition has no data. The individual objects have the data, but the class specifies what kind of data they have. For attributes, you may also see them referred to as properties or state or just generally as data. And behavior is also referred to as actions or operations. It means what operations does this class have? What can it do? Now, when we write attributes in code, we declare variables, and for behavior, we define methods or member functions. Methods are used to process the variables. Now, if you come from a non-object-oriented programming language where you are familiar with functions, you can think of methods or member functions as simply being functions that belong to a class. Now, every object maintains its own attributes. These attributes are carried with the object as it is used in a program. They are specified as a part of the object's class. So, here is an example. If your application deals with banking, you might create a bank account class, and it will then have attributes to it. The class says that each object has an account number attribute, but it doesn't say what the account number is. It says each bank account object has a balance attribute that represents the amount of money in the account, but it doesn't say what the balance is. Each bank account object knows the balance in the account it represents, but not the balances of other accounts in the bank. Attributes are specified by the class's instance variables, and behavior might say we have got deposit, withdraw, fund transfer, and inquiry of the current balance. After writing the class, we can then create objects based on that class. The other term that we use is we are creating instances of a class. Each object is an instance of a particular class. The process of creating these objects is called instantiation. When we create an object, we can access its variables and methods. Thus, a class is a logical construct. An object has physical reality. Now, each instance, each object, no matter how many, has its own identity independent from other objects, and its own data and its own behavior. So the class says that each object has a balance, but the individual objects may have a balance of 500 or 5000 or 0. We can deposit to one account object and withdraw from another account object, and each behavior is independent. So, if we want to create objects, we need the class first, and if we haven't designed the class ourselves, someone else have to design it already. Now, in most object-oriented languages, there are a lot of classes already written for you that come along with the language for such diverse purposes as user interface design, dates and calendars, collections and I/O. These classes are written and then gathered together into frameworks or libraries. In Java, you have Java class library, about 6000 classes available to you. And the .NET framework for C# and VB.NET has even more than that. C++ has the C++ standard library. But even though we might have a lot of classes available to us, in any significant application, we will still need to write our own classes. And we need this to describe the objects of the real-world entities and concepts of our application, called the problem domain, and to adapt the classes that are supplied by the standard library to our own purposes.